All right, welcome. Thanks for joining section 5.4 notes. What we're going over in section 5.4, the notes portion will be a little bit quick. We'll go through a couple examples in it as well. And we're just going through some new formulas. So talking about some of those identities that we had done before. These aren't exactly identities, they're formulas, but they do require memorization, and they're really not that bad once you start using them. So the sum and difference formulas. First, you have the sine of u plus v is equal to sine u cosine v plus cosine u plus sine v. So essentially you're saying the sine of the first angle times the cosine of the second plus the cosine of the second angle, cosine of the first angle, sine of the second. And this could be written in different ways. One way in which sometimes I end up writing it is sine u cosine v plus sine v cosine u. It's the same thing. It's just this second term. Sometimes I write it backwards, and I don't want that to confuse you if you see it that way. The only reason I do that is that way both times it's starting with sine, and the angles are just what's changing. Here, the first time it's always angle u, the second time it's always angle v, but the trig function is changing. The sine of u minus v is going to be sine of u cosine v minus cosine u sine v. So same equation, just I'm going to subtract instead of add. When we're talking about what u and v are, what u and v just represent two angles that I am adding together. And you'll see why this would be a useful formula. The sum and difference formulas apply to sums and differences of angles only, not the trig functions themselves. So that's an important thing to note. This does not apply to, for instance, something like the sine of 30 degrees plus the sine of 50 degrees. This does not indicate or is not an example of this scenario. This is talking about the sine of the sum of angles. This is talking about the sum of the sine of angles, and you do that differently. This is easier. Talking about some more then, if we have the cosine of u plus v is equal to cosine u cosine v minus sine u sine v. So cosine a little bit tricky. You got to think about the fact that cosine is sort of like our x coordinates. And any of those things that were ever x, we always said that they were counterintuitive. So I see this addition, it really means subtraction for cosine. And then note that the formulas themselves are different. Here, I have sine and cosine on the left, sine and cosine on the right. Here, it's cosines on the left, sines on the right. The addition tells me that I will subtract. The subtraction tells me that I will add. And again, it's a little bit tough. You have to make sure that you memorize that. But it's just something that you do. And once you start using them in some of the homework problems, it doesn't get too bad. Tangent of u plus v can be written as the tangent of u plus the tangent of v over 1 minus the product of tangent u tangent v. And tangent of u minus v is just tangent u minus v over 1 plus the product of tangent u tangent v. So when you're looking at these, you're like, whoa, that's 6 formulas to remember. But if you have this sine u plus v1 down, these are almost identical. The only thing that's switching is the sign. Cosine, if you have down like where the structure of it is, only thing that's changing is positives and negatives. Same thing with tangent. Only thing changing is positives and negatives. So as long as you know one of them, then you're going to know the other one just by default. All right, so then we're just going to do, I think, 4 slides of examples, just to make sure that you know how it sort of works. So use the sum and difference identities to find the exact value of something like sine of pi 12ths. And I gave you a little hint here that wouldn't be given in something like the book or on a quiz. Pi 12ths can be written as pi thirds minus pi fourths. So this is really the sine of pi thirds minus pi fourths. So this is really like our u, and this is our v. And our formula for the subtraction of sine is that you do sine of u, the cosine of v, minus the cosine of u, the sine of v. So I'm talking about this formula, sine of u minus v. And I believe I wrote it the exact way that you have it there, yeah. So now just putting that in, this becomes the sine of pi thirds, u, times the cosine of pi fourths, minus the cosine of pi fourths, the cosine of pi thirds, this is a u, times the sine of pi fourths. One thing that sometimes is helpful in these problems is if you know you're using these angles, I sort of think about those coordinates. So pi thirds and pi fourths. Pi fourths is root 2 over 2 comma root 2 over 2. And pi thirds is going to be 1/2 comma root 3 over 2. Remember that these are our cosines and our sines. So the sine of pi thirds means root 3 over 2 times the cosine of pi fourths, here's cosine, pi fourths, root 2 over 2, minus the cosine of pi thirds, 1/2, times the sine of pi fourths, root 2 over 2. This gives me root 6 over 4, minus root 2 over 4, which is root 6 minus root 2 all over 4. I can't subtract these because they're not the same thing inside the radical. So you would just leave it exactly like this, root 6 minus root 2 over 4. Find the exact value of cosine of 15 degrees. So I didn't give you a hint and tell you how to split this, and you are able to split this in any way, shape, or form where your sum or difference comes up to 15 degrees. Personally, what I'm going to use is the cosine of 45 minus 30. Again, this is in terms of degrees. So off to the side, I usually list again, well, I wanted that to be a 4. 45 degrees and 30 degrees, what those coordinates are. So this is root 2 over 2 comma root 2 over 2. And 30 degrees is root 3 over 2 comma 1/2. My cosine formula says that I do the cosine of both angles. So the cosine, if I said this is u and v, it's cosine of u, cosine of v, then the opposite sign. So plus the sine of u, the sine of v. So cosine of 45 degrees, remember here's cosine and sine, root 2 over 2, times the cosine of 30 degrees, root 3 over 2, plus the sine of 45 degrees, root 2 over 2, times the sine of 30 degrees, 1/2. This gives me root 6 over 4 plus root 2 over 4. So root 6 plus root 2 over 4. And same thing as the previous problem, I can't combine those in any way, I just leave it as root 6 plus root 2 over 4. All right, only 2 more examples left. Find the exact value of the tangent of 11 pi 12ths. And once again, here I gave you a hint that 11 pi 12ths is the same thing as 3 pi 4ths plus pi 6ths. So this can be written as the tangent of 3 pi 4ths plus pi 6ths, where here I have u and here I have v. Tangent formula, a little bit stickier for you to try and remember. That one's going to be tangent u. Here, I have addition, so I keep addition on top, plus tangent v, over 1 minus the product of tangent u and tangent v. So with that in mind, now all I have to do is go substitute that in and keep in mind the unit circle. So the tangent of 3 pi 4ths plus the tangent of pi 6ths over 1 minus the tangent of 3 pi 4ths, the tangent of pi 6. For our tangents, if we're talking about 3 pi 4ths, our tangent there is going to be -1. And if we're talking about pi 6, our tangent there is root 3 over 3. So this becomes -1 plus root 3 over 3 over 1 minus -1 times root 3 over 3. which becomes negative 1 plus root 3 over 3 times 1 plus root 3 over 3. And we can sort of do a lot here and probably different ways. We need to sort of rationalize this because you have that square root down in the denominator. So the first thing I'm going to do is say this is really like negative 3 over 3 plus root 3 over 3 over 3 over 3 plus root 3 over 3. So I just rewrote the 1s as 3/3 so that I can get rid of these 3's. So this became negative 3 plus root 3 over 3 plus root 3. And then I'm going to multiply this by the conjugate. So I'm going to swipe this screen over. So if I multiply this by the conjugate, I'm multiplying by 3 minus root 3. In the denominator, I'm going to get 9 minus 3. And in the numerator, I have to multiply all that out. I get negative 9 plus 3 root 3 plus 3 root 3 minus 3, which gives me negative 12 plus 6 root 3. So negative 9 and negative 3 gave me negative 12. 3 root 3 and 3 root 3 gives me 6 root 3, all over 6. At that point, you can do this cross reducing. So negative 12 over 6 is negative 2. 6 over 6 gives me 1 square root 3. All of that is required, and I'll let you know that it becomes pretty common in these tangent problems where you have to do that reduction. Now, be able to just get this in the first place, that's going to be the most important first step. And then all of this is just sort of algebraic simplification. All right, one more quick, easy question. Use the sum or difference identity to condense the given expression into a single trig expression. So I'm trying to condense here, which means what I've given you is something that is already sort of in the form of the formula. So this is sine u cosine v minus cosine u sine v. So when I do this, the first thing that I realize is the sine and cosine are on the same sides. So I've got a sine and cosine on the left, sine and cosine on the right. That tells me that it's a sine equation. And with sine, subtraction means subtraction. So this is a sine u minus v. So it would be sine of 4.2 minus 1.7, which then gives me the sine of 2.5. So our final answer is just sine of 2.5. Again, here's u and v. That's a terrible v. And v. I notice that the cosines are on the left, the sines are on the right. That tells me it's a cosine function. And cosine is counterintuitive. So where I see subtraction, that means I'm actually adding u plus v. So this is the cosine of, let me just fix that. 57, I fixed it and it still doesn't even look good, plus 34. That gives me the cosine of 91 degrees. All right, that's it for the notes video. There obviously are some more examples. Those are a little bit more of in-depth examples, and I just wanted to knock out these easier ones right away. So feel free to go watch that optional video, see what those things are like. Some of them are a little bit, I'll say wonky, for a lack of a better word.